Hi, I am Akhilesh Kumar Srivastava from ABES Engineering College, Ghaziabad. In today's lecture, we will discuss about the Hackerrank problem, cutting paper squares. So here is the problem statement. Mary has an n cross m piece of paper that she wants to cut into 1 cross 1 pieces according to the following rules. She can only cut the one piece of paper at a time, meaning that she cannot fold the paper or layer already cut pieces on top of one another. Each cut is a straight line from one side of the paper to the other side of the paper. So the two rules says that I can do only one cutting at a time, and cutting is required to be done from one side of the paper to the other. For example, in this paper, I can cut from this place to this place, or I can do the cutting here like this, or I can do the cutting like this. So if I am doing the cutting from here, my piece of the paper, which earlier was 3 cross 2, has got divided into two pieces of the papers, one of size 1 cross 2 and the other one of size 2 cross 2. Similarly, if I do the cutting from here, my piece of the paper has now been divided into two papers, one of size 2 cross 2 and the other one of size 1 cross 2. Similarly, if I am doing the cutting from here, my piece of the paper has got divided into two parts or two pieces of the paper, one of the size 3 cross 1 and other one or two of size 3 cross 1. So this is the second rule. What the first rule is saying, if I have made the two pieces, I cannot put the other one on the top of other one. Here we have a 3 cross 1 piece and a 3 cross 1 piece. These two have to be dealt separately. It may not happen that 3 cross 1 paper is put above the 3 cross 1 paper and we do the cutting. So it is not allowed. So the 3 cross 1 paper has to be dealt separately, and the other 3 cross 1 paper is also required to be dealt separately. Now look at the constraint. The constraint says that n and m may be 10 raised to the power 9 or less. It means that whatever solution we are going to find out for this problem, we have to restrict our solution in either order of n or less. If we find the solution in the constant time, that will be the best solution, and we should actually think in that manner only. Here the task is that we have to divide the piece of the paper into 1 cross 1 sizes. So the input format is a single line of two space separated integers denoting the respective value of n and m, where n stands for the row height and m stands for the column height. Or you can say that m stands for length and m stands for width. Output is print a long integer denoting the minimum number of cuts needed to cut the entire paper into 1 cross 1 squares. So ultimately the target is that we have to find the 1 cross 1 squares. So what will be the minimum number of cuts required to obtain this? So let's see with the example. So we have a 3 cross 1 paper. There are two ways by which this 3 cross 1 paper can be cut in initially. So either we cut from here. So I obtain a 1 cross 1 and a 2 cross 1 paper. So this 1 cross 1 paper is done because we had to find out the 1 cross 1 square only. The second one can be cut from here, obtaining the 1 cross 1 above and 1 cross 1 square below. So in two cuts, I was able to find out the 1 cross 1 square. The other approach may be, let me do the first cut from here. So if I do the first cut from here, at the bottom side I am getting a 1 cross 1 square. On the above I remain with a 2 cross 1 paper. If I cut again here, then I get the two pieces of the papers which are 1 cross 1 size. So the target is achieved in two cuts. So either we follow this rule or we follow this rule. we are actually getting 1 cross 1 pieces in 2 cuts. Let's take some examples to understand. Let us say we have a 2 cross 3 paper. So if I do the first cutting, let's say I do it from here. Then I get a 1 cross 3 paper and a 1 cross 3 paper. In the previous example we have seen that the 1 cross 3 paper can be cut into 1 cross 1 square in 2 steps. So I require 2 steps to convert the above part of the paper into the 1 cross 1 square, and the same is the size of the below paper or below piece of the paper. So 2 steps will be required here also. So 1 cut was required for dividing this piece of the paper into 2 parts. Another 2 cut is required to obtain 1 cross 1 for a 1 cross 3 grid or 1 cross 3 paper, and the same number of cuts required for the another piece of the paper. So 1 plus 2 plus 2, I require 5 cuts to obtain a 1 cross 1 piece of the paper. If I see this example, in this example also, let's cut it from here. Then I have a 2 cross 1 piece and a 2 cross 1 piece. So 2 papers of size 2 cross 1. Now if I have a 2 cross 1 piece, I can make 1 cut from here to here, and I can get the 2 1 cross 1 piece of the paper. The similar cut can be applied here also, and we will get a 1 cross 1 piece of the paper. So in total, I require 3 cuts. One is this one, to divide this paper into 2 halves of 2 cross 1 and 2 cross 1 pieces. And then 1 cut each is required for converting the 2 cross 1 piece of the paper to 1 cross 1. So in total, I require 3 cuts. If I do the cut from the other side, for example, this is the piece of the paper. Instead of vertically cutting this paper, if I do it horizontally, then I get a 1 cross 2 paper, and another one also of 1 cross 2 size. And then for 1 cross 2, if I apply a cut here, I get a 2 piece of the paper of 1 cross 1 size. And if I cut it from here, then also I will get 1 cross 1 piece of size. Now, here also I require 3 cuts for preparing the 1 cross 1 piece of the paper. Let's say I have this question where the piece of the paper is of size 4 cross 4. If I divide this piece of the paper vertically like this, then I obtain a 4 cross 2 paper on left side and 4 cross 2 paper on the right hand side. If the 4 cross 2 paper is further divided or further cut into 2 pieces, then I get a 2 cross 2 piece above and 2 cross 2 piece below. Similarly, the another part, which is also of size 4 cross 2, if I cut it from very mid, I get a 2 cross 2 paper ahead, above, and 2 cross 2 paper below. Now, with the previous examples or with the previous experience, we have seen that the 2 cross 2 paper can be converted into 1 cross 1 piece of the paper in 3 steps or 3 cuts. So all these 2 cross 2 papers will require 3 cuts to obtain a 1 cross 1 paper. So in total, I first have done these 2 cuts to obtain the 2 cross 2 piece of the paper. Fine. First I did, let's say, first was this cut. And the second one, after doing this, I had the 2 pieces of the paper. So second one was this one. And then for the another piece of the paper, third one was this one. So 1 plus 2 plus 3, so 1 plus 1 plus 1, these are the 3 cuts to obtain the 2 cross 2 grids. And when the 2 cross 2 grids were divided or cut into the 1 cross 1 pieces, we require 3 plus 3 plus 3 plus 3. It means a total of 15 cuts are required to obtain this. Let's once again see this example, and let's do the cutting and see what are the possible cuts for this 3x2 paper. Let's say I am first cutting this paper like this. I obtain a 1x2 grid above and 2x2 grid below. And for the 1x2, if I cut it from here, I obtain the 1x1 piece of the paper. So one cut is required. And if a 2x2 piece of the paper is there, then I require 3 steps or 3 cuts. We already have seen with the previous example. So a total of 5 cuts is required for this. Similarly, in spite of going for the option 1, if we go for the option 2 and we first cut the paper from here, so I obtain a 2x2 piece of the paper above and 1x2 paper below. So if 2x2 paper is there, I can find the 1x1 papers in 3 cuts. And for 1x2, if I cut it from here, I get a 1x1 piece of the paper. So one step is required for this. So in total, I require 1 plus 3 plus 1 means 5 cuts. Similarly, if I have this paper and I cut it from vertically top to bottom, then I get 2 pieces of the paper of size 3x1 each. We already have seen that if I have a 3x1 paper, I require 2 cuts. So 2 cuts are required for one side and the 2 cuts are required for the another side as well. So in total, I require 2 plus 2 plus 1. It means 5. So in either way we do the cutting, we are requiring 5 cuts for doing so. So let's actually brief out what actually the examples we have seen and what they are telling us. If I have a 1x3 or 3x1 piece of the paper, I require 2 cuts. If I have a 2x2 paper, I require 3 cuts. And if I have a 2x3 paper or 3x2 paper, I require 5 cuts. If I have a 4x4 paper, then I require 15 cuts. A solution can be thought of as, if we have already found the solution or the number of cuts required for the smaller piece of the paper, then that can be utilized for finding out the solution of the larger cuts. It means that we will have to backtrack, or we will have to see the solution of the larger problem with respect to the solution of the smaller problems. So this can be done recursively. But the recursive solution also will require a lot of time. Let us think differently and see what the N and M are playing the role for finding out the solution. Let's take the example. 1 cross 3 is 3, or if you multiply this 1 and 3, so this is 3, and 3 cross 1 is also 3. If I obtain 3 minus 1, this is giving us the value 2. Similarly, I have 2 cross 2 piece of the paper. If I multiply these two, the answer is 4. If I subtract 1 from this, I obtain 3. If I have a 2 cross 3 paper or 3 cross 2 paper, then the multiplication of the N and M is giving us 6. If I subtract 1 from this, I obtain 5. Similarly, if I multiply 4 with 4, that is N and M, I obtain 16. If I subtract 1 from this, I'll get 15. So it looks like the solution is you multiply N with M and you subtract 1 from this and you get the answer. So this can be done in constant time. Given the value of N and M, you can obtain the solution in the constant time. So here is the pseudocode. Here the rows of the grid is N, the columns of the grid is M. You simply multiply N and M and save in some different variable, let's say X, and you return X minus 1, which is giving you the answer. Let us now solve this problem at Hackerrank. So here is the interface at which we have to solve this problem at Hackerrank. Let me select a language C to write the code. In this I have solve function, which already has the value of n and m, where n stands for the row height and m stands for the column height. And we have to return the answer in long. Let's say that I have a variable x which will store the multiplied values of n and n, and we will return x minus 1. But this answer is not that very simple. We will first have to understand the multiplication of n and m. Let's say n is a very large quantity and m is also a very large quantity. In that case, the multiplication of integer with an integer value will give us integer. In case the value of n and m is crossing the limit of integer, in that case I will start getting the negative values, because you must be knowing that if the ranges are crossed for the value of any integer, we go in a cycle. We will go towards the negative part. So to find out the correct answer, let's take two different variables, a and b, and let's save the values of m and n in a and b. A stores the value of n and b stores the value of m. Then we are going to multiply the values of a and b. Since a and b are the long numbers, in that case, save the value of n and m in long. Then the multiplied value of a and b will also be long. Long increases the range of the numbers that we are dealing with. And finally, we have multiplied these values to store in x, and we have returned the x value. Let's run this code and see if the sample test case is running. Now that the sample test case has passed, let's submit this code to find out if other tests are running fine. You can see that all cases which were given are in green color, that they have got passed. Thank you.